Hello students, welcome to this session JEE Main Test 2007. 3 shifts have already gone, I think, when I am uploading it. So still I decided for the remaining students that who are doing it, it might be my help from my side. So 3 questions are tough, 22 is really tough, 12 were medium, 10 were easy. So again, overall a nicely balanced paper. Almost that is a sort of paper that we are getting in the shifts here. So as per me, this is 10 and 6, 16 questions. So 60 marks should be gettable in this paper, and those who are very good should get 80 plus in this particular test. Let's begin. If K1, K2 are maximum kinetic energy of photoelectrons emitted when light of lambda 1, lambda 2 is incident on surface, lambda 1 is thrice of lambda 2. So what I can say, E2 would be equal to thrice of E1 because energy is inverse to lambda. So first of all, K1 would be equal to energy of photon E1 minus 5. And K2 is E2 minus 5, which is 3 E1 minus 5, and we know is greater than definitely 3 E1 minus 3 5. So what I can say, K2 is greater than 3 times E1 minus 5, or K2 is greater than thrice of K1. So K2 is greater than thrice of K1. So what we have, this is the option that we will get, option B from here. Next one, a solid sphere and a hollow sphere of the same mass and radius are given a spin about their cm, and then they are placed on a rough horizontal surface. Spin angular velocity is same and it is omega naught. Once the pure rolling start, let V1 and V2 be the linear speeds then. So when we have situation like this, so this is given a spin, just a spin omega naught. So finally whenever it will start pure rolling, it would be omega, and we will write it as omega by r, or we can write it as V and V by r. This would be V and this would be V by r. So about this initial point of contact P, we apply angular momentum conservation because the torque about this point will remain 0. So initial angular momentum, what we can write here, the initial angular momentum about this was equal to ICM omega naught, and finally it becomes ICM plus mr square into omega, that is V by r. So V will be equal to, you can write ICM upon ICM plus mr square into omega naught r, or you can say 1 upon 1 plus mr square upon ICM into omega naught r. You clearly know the ICM of hollow is greater, so for hollow this term is going to be smaller, so denominator is smaller, so that is going to be, what we can say, would be greater. So definitely the hollow sphere will have a more velocity, so V2 will be greater than V1. You can directly go for this particular concept. Next, so V2 is greater than V1. Which option I am getting? The option that I am getting, V2 greater than V1, that is option C. Next one, a hollow charged metal sphere has a radius r. If the potential difference between surface and a point at a distance 3r from the center is E, then the electric field intensity at distance 3r from the center is, okay, so V is what we can say, it is kq by r minus kq by 3r. You can write like this. So that is equal to 2 kq by 3r, and electric field at that point, you know, is kq by 9r square. You can directly write it like this. So kq by 9r square. So if we do this, in this kq by r, we can write this kq by r as 3v by 2. So that is 3v by 2 upon 9r. We can write kq by r. So this becomes basically what we get, v by 6r. So go for option A here. Simple question for you. Next one, you have a sphere of 0.1 meter radius, mass is 8 pi kg, attached to lower end of a steel wire, length 5, and this wire is suspended from a 5.22 meter high ceiling. When the sphere is made to swing like a simple pendulum, it just grazes the floor. That means at that point the length is 5.22. Calculate the velocity of the sphere at the lowest point. So first of all, this is 5 and the diameter would be 0.2. That means the extension in the wire is 0.02 meters. So I can make it out, the force you know is Ay by L into delta L. So what we can write, A is what we have, A is the area of the area is needed or not, the area is given, yes, the diameter is given, so it is pi, d square 10 to the power minus 6 by 4, y is 1.994 into 10 to the power 11, length is 5, and extension is, doing this, what we will get, 6 and 11, 5 and 2 will go 10 to the power 3 into 2 pi into 1.994 upon 20. So this become 10. So this is 100. So it is 199.4 pi. Okay, this is the force. Now we write the equation, F minus mg is mv square by r. R would be 5.1 or 5.12, it doesn't matter. So V comes out as root of r by m, that is 5.1 upon m is 8 pi and this would be 199.4 pi minus mg would be 8 pi into g. So this pi goes. So what we are left with here, if I check it, it comes out as this is what we get. Okay, this would be t minus mg we have got. So this is 5.1 into 199.4 minus 80. So 199.4 minus 80, that will be basically what we can say, this would be 119.4 we can write. So it is 119.4 into 5 by 8. So this is approximately 15 times. If I do 120, 15 5s are, you have 75 something approx. So 75 something approx, so it would be 8 point something. Go for option D, you can directly make it out. So this is one of the question that you must have done in your exercises. Small ring of mass m is constrained to slide along a horizontal wire fixed along two rigid supports. The ring is connected to a particle of same mass by an ideal string, and the whole system is released from rest as shown in figure. If the coefficient of friction between A and wire is 3 by 5, the ring will start sliding when the connecting string will make an angle theta with the vertical, then theta will be. So what will happen here? Just look. This angle with the vertical is theta. So what I can make it out, till it moves, it will be, let's say, in a free fall not, but it would be on a pendulum like structure. So it has gone by theta. So I can say its velocity would be root 2 gh, h would be r cos theta. So it would be root 2 g l cos theta or r cos theta, whatever you write. So what we can make it out, the tension in the string will be mg plus mv square by r, that is equal to 2 mg cos theta. So that is 3 mg cos theta, that is the tension, and this is pulling it like this. And if I take this component is t sin theta, this is now ultimately balancing this fs max. And for fs max, if I apply, what we will have, n would be equal to mg plus t cos theta. So fs max would be equal to mu sn, that is 3 by 5 into mg plus 3 mg cos theta. So this is one of the equation. So equating it, so t sin theta means t 3 mg cos theta sin theta is equal to 3 by 5 mg plus 9 by 5 mg cos of theta. So this mg goes. Now what we are left with, this is now a dubious one, or try it. Take it here, 3 minus 9 by 5, 15 minus 9, 6 by no, it won't be cancelling like this. We have to do it. Let's say 3 cos theta I take as common. So it would be 3 cos theta, if I have taken as common, it would be sine of theta minus 3 by 5 cos theta is equal to 3 by 5. That is what I am getting. So what would be the theta here? Now better try the options instead of solving. I think that would be a far easier option as per me. This was t cos theta. Okay, this is cos square theta. So again a mistake. Okay, I have done it right. That should be 3 by 5 cos theta. Okay, otherwise it should have been 3 by 5. So the equation is ultimately correct, but let me try it. Let's try with 30 degree. 30 degree, I think the root won't be cancelling out, so no point in trying. 45. If I try 45, it is 1 by root 2. 1 by root 2 minus 3 by 5 root 2. So what we will have here, it will come out as 5 minus 3, 2 by root 2. So 3 into 1 by 2 into 2 by 5 it will become. So this is 3 by 5. Yes, so 45 degree is matching up. So it's the way, otherwise you can use your trigonometry, because it is a cos square theta thing, you can convert it into sin theta or whatever you like, but this is the way I will try. It's an easy one to put the values here. For what distance? Ray optics is a good approximation when the aperture is 4 mm and the wavelength. This is the Fresnel distance. You should remember. Now most of the students don't remember this. A square, that is 4 mm square, 16 into 10 to the power minus 6, and lambda is 400 into 10 to the power minus 9. So 9, and this is 8. So this is 10 to the power 1 will go up. So 160 by 4. 160 by 4 means 40 meters. Up to 40 meter ray optics is valid. Up beyond that it won't be. A solid sphere of uniform density radius r applies a gravitational force of attraction equal to F1 on a particle placed at P. Okay, distance 2r from center O. A spherical cavity is now made. The sphere with the cavity now applies a force F2. The ratio of F2 by F1 is First of all, what would be F1? F1 you can directly write as G total mass upon 2r whole square, that is gm by 4r square. Now take the effect of cavity only, because this is equal to F2 plus f of cavity, that is equal to F1. So what is f of cavity? The direction will be same. So f of cavity, if I calculate, because radius is half, its mass would be m by 8. So it would be g m by 8, and from its center the distance would be 3r by 2 whole square. So it would be 4 gm by 8 into 9r square, that you can write it as gm by 18r square. That is what you are getting. So you can simplify it as 2 by 9 gm by 4r square, if I am right. That is 2 by 9 of F1. That means F2 will be equal to 7 by 9 of F1. Directly you can make it out. So the ratio F2 by F1 is 7 by 9. Go for option B, not that tough one. Next, ball is projected from point A with a velocity 10 meter per second normal to the inclined plane as shown in the figure. Range of the ball and the inclined plane will be. So just take it as y-axis, take it as x-axis. First of all, time of flight I can calculate. So delta y I have to do 0. So 0 is equal to initial velocity was in y, that is equal to 10t minus half. Acceleration component would be g cos 30 here into t square. So 10t is equal to 5 cos 30 is root 3 by 2 t square. So t directly I can make it out 20 by 5 root 3 or 4 by root 3 seconds. So the range would be uxt is 0 plus half g sin theta into t square. That is half into 10 into sin 30 is 1 by 2 t square is 16 by 3. So 2 to the 4, 40 by 3 meters we are getting the answer. So this is a simple application of projectile on an incline. You must have done such profiles. If the series limit of the Lyman is 912, then the series limit of the Balmer will be. So what we can say, for the series limit of Lyman the energy is 13.6 eV. For this Balmer one it would be 13.6 into 1 by 4. So energy is 1/4, so lambda will become 4 times. So 4 into 912, this is 3648. You can directly go for it without doing any calculations. Tennis ball of mass m2 sits on the top of a basketball of a mass m1. The bottom of the basketball is at a height h above the ground, and the bottom of the tennis ball is at a height h plus d above the ground. Okay. Balls are dropped from rest. Here all collisions are elastic, and m1 is much greater than m2. The height from the point of collision up to which the tennis ball bounce. The height from the point of collision up to which the tennis ball will bounce. So first of all, when they are going to hit, you know, the speed of all will be this, and this both will be root 2 gh for sure. So now they strikes with the root 2 gh. Now what happens now? Now the collision will be this collides with this collides with this. Okay. So the tennis ball velocity after the collision. So first, taking the elastic collision, we can say the first ball you can write, let's say both were at root 2 gh. This ball now will go with a velocity root 2 gh upwards because it is an elastic collision, and just if I take this is going at root 2 gh now. So taking it as an elastic collision between one is very lighter and one is very heavier, I can say even after collision it will go with root 2 gh because its velocity will remain same and its velocity become v, and we will simply apply velocity of approach equals velocity of separation. So here velocity of approach was 2 root 2 gh, here velocity of separation would be v minus root 2 gh. So v comes out as root 2 gh, 3 root 2 gh, I can make it out. So it's a nice thing, 3 root 2 gh. So the height it will gain. Height would be v square by 2g, that would be 9 into 2gh by 2g. So this is that is going to be 9h. So it's a nice question. So what we have taken first the collision of this, and then on the next moment the collision between these two, otherwise we won't be able to get it. So it's a nice question, it would be 9h. Next, density of electron hole pair in a pure germanium, that is what we call as Ni, on doping with the hole density, that is Nh. So what would be Ni? Ni you can write as Ni square by Nh, that is the what we call the law of mass action. So 9 into 10 to the power 32 divided by 4.5 into 10 to the power 22. So 2 in 10 ki power 10, that would be the concentration of electrons. Go for the option B here. Next, the potential energy of a force field is like this. The force acting on the particle will be, so F would be, we can write Fx would be minus del u by del x. Minus del u by del x, if you do cos derivative is minus sine, so it will become plus sine of x plus y, and similarly Fy will also become like this. This would be the same, it would be also sine of x plus y. So at the given point the force would be sine of pi by 4 I cap plus sine of pi by 4 j cap. So 1 by root 2 I plus 1 by root 2 j. So go for option B in this particular case. Next one. Long rigid wire lies along the x-axis, carries a current 10 ampere in the positive x, and around the wire the external magnetic field, okay, this field is interesting, with x in meter, b in Tesla. The magnetic force on the segment of the wire between 1 and 4 is okay. So this is a wire carrying current here. Now what we have, field is I plus 2x square j cap. So field is somewhere here, so it would be, as the x is increasing, it would be going more and more like this. So this would be the field line, I suppose. So you have to find the force on the segment of the wire between 1 and 4, between A and B, let's say 1 and 4. So what we can do, go at a distance, let's say, let it take first here at any distance x and take a small dx. So the force, we write it as BIL, and we take the force which is perpendicular to the length of the wire, the component of B perpendicular to the wire, so that would be BY I into L, that is dx. So that is a small force. So BY at this point is 2x square, I is 10 into dx, and now you have to integrate it. So what you have, 20x square dx, just integrate it from 1 to 4. So it was looking tough, but it isn't tough. X cube by 3, that is 4 cube by 3 minus 1 cube by 3, 64 minus 1, 63 by 3, that is 21, 20 into 21 is 420 Newton, that we will go for. So option D is the answer that you will get, and just check what would be the direction. Next, point object O is placed on the principal axis of a convex lens of focal length 20 cm at a distance of 40 cm to the left of it, that means at the 2f. Diameter of the lens is 10 cm. The eye is placed 60 cm to the right of the lens and a distance h below the principal axis. The maximum height of h to see the images. So what we can see with this is, again, we can say it depends on what we call as the I'm missing this, the field of view thing. Okay, so it is 40, that is 2f. So if I can draw this symmetrically, it is a point object, so it will be going like this, and it would be going like this, it would be going like this, it would be going like this, and I think this is a repeated one. So this distance will also be 40, and here is the eye 60. So what distance h below it can have? So just using this symmetric triangle, this diameter was given as 10, so this is 5. So what we can write, 5 by 40 would be equal to h by this remaining distance is 20. So what we can say, h is 2.5 centimeter. Go for B. Simple. You have to draw this ray diagram and you are there with the answer. Next one. Block of mass 1 kg moving on the x-axis. The force affecting on the block is shown. The velocity of the block at 2 seconds is minus 3 meter per second. What is the speed of the block at 4 seconds? So FT graphs gives you a change in momentum. So 2 and 4, if I check, the net impulse delivered is 0. So the velocity will remain minus 3. So speed will remain 3. That's an easy one. Next one. The period of oscillation of pendulum is this is the length of the pendulum, and this is the percentage error in G's. So G is 4 pi square L by T square, you know. So error in G is error in L 1 times plus twice the fractional error in the time. So delta L by L, 0.01 by 10, let's say in percent into 100%, do it, and 2 delta T 0.02 upon 0.5 into 100%. So it is 1 by 10, that is 0.1%. This is what we will have. This will become 0.2 by 5, 0.4 by 5, 40 by 5. This would be 8% now. So okay, so it would be 8.1%. So it is approximately 8.1% here. So you can go for 8% option here. Next one. Ice starts forming in a lake when the water is at 0 and the ambient temperature is minus 10. If the time taken for 1 centimeter of ice to be formed is 7 hours, then the time taken for the thickness of ice to change from 1 centimeter to 2 centimeter. Now this is the concept that you might be remembering directly. I am not doing the complete derivation that is done, that is given in your NTA solution, you can check, but typically this is treated and we are advised typically for such a question. We simply say the time taken for a thickness to develop, let's say a thickness T, is directly proportional to T square. So what I can say, from 0 to T thickness, let's say what is given, 0 to, let's say 1 centimeter, we can say 0 to 1 centimeter if I do. So let's say if for 0 to 1 centimeter, let's say time is t naught. So from 0 to 2 centimeter, the time would be equal to 4 t naught. That means from 1 to 2, it would be triple the time taken to generate 0 to 1. That is triple, that means 21 hours. You can directly say this difference is going to be 3 t naught, which is 21 hours. So you can go do directly by this. This is generally stated. You will see in books also that is directly given. Now a mole of an ideal gas goes through the process P is equal to this. Then change in temperature of the gas when volume changes is okay. So what you can do, because it is an ideal gas, PV is equal to nRT. You can do with this thing always. So first of all, the pressure when it was 1 meter cube was equal to 2V square upon 1 plus V square, that is 2 upon 1 plus 1, that is 1. And the pressure when volume is 2 meter cube will become 2 into 2 square upon 1 plus 2 square, that is 8 by 5. So what we can see, delta T, initial temperature T1 was equal to, the P was 1 and the volume was 1 upon what we can write as 1 upon NR, N was 1 into R. Now the T2 would be, now the pressure is 8 by 5, the volume is 2 upon 1 into R, so that is 16 by 5 R. So the difference is T2 minus T1, that would be 16 by 5 minus 1, that is 11 by 5 R. So go for option B. Just do what the question says, put it, it's a simple, do whatever it is saying. Atomic masses of deuteron, helium given, this is 4 helium, this should be a printing mistake here. Taking the velocity of light in vacuum to be this, calculate the amount of energy liberated when 2 moles undergo fusion to form this. So again, this is a printing error, but don't worry. Amount of energy when 2 moles, now 2 moles means 1 mole reaction will take place. So first of all, I can calculate for a single reaction, 2H1 to 4 helium. So the mass defect I will write as 4.0026 and 4.0282 minus this. So this is it, what we will have. This is given in 4 digits, this is also in 4 digits. 12 minus 6 is 6, 7 minus 2 is 5, 2 minus 0 is 0.0256 U. So the energy in single reaction would be 0.0256 U into 931.5. You say MEV by U, right? So MEV by U and U cancel and convert it. We know 1.6 into 10 to the power minus 13 joule is equal to 1 MEV. So this is what we'll get it in joule. So what we get, we have to, okay, so the powers are also same. We will have to do some rigorous calculations. We are not left with any choice. So this is let's say this is 256 I can write, this is 931.5 I can write, and 1.6, and this will become 10 to the power minus 17 joules. Now this is for what we say for the single reaction. For 1 mole we can say energy would be 6.02 into 10 to the power 23 into this 256 into 931.5 into 1.6 into 10 to the power minus 17. That is what you will get. So what we will have, this 23 and 17, this will be 10 to the power 6. And if I do this 6.02 into 1.6, I can write it as 0.256 and I can write it as 0.9315, and this becomes 10 to the power 12, that's 6 and 6. So we get this power. Now we have to check which is closer to this. So 16 6 is 96, so it would be 9.6, and it is 0.256 into 9.315. So let me take it as 0.6, let me take it as 930 to simplify 0.93. So 9.6 into 0.26 into 9.3, 26 3s, if I do 26 3s is what we say is 5278, 26 9s are 260, 240, 234, 234 and 7 241. I am assuming I am doing right. So 0.2418. So 9.6 into, so it would be tricky. It would be 2.3. It won't be 2.9. It would be 2.3, closest one. So I'll go for this one. So this is how I have calculated. Otherwise this will be a tougher one to calculate. Car is going towards a high cliff. The driver sounds a horn of frequency F. Reflected sound here, it's 2F. If V is the velocity of the sound, the velocity of the car in the same velocity units is. So first of all, what is the sound the hill receives? The hill receives would be F naught, or you can say F here. Because the hill is at rest, it is V, but car is going towards us, that is V minus V car. Now the frequency of the echo heard would be, this is frequency from hill, because the car is going towards it, V plus V car upon V, so that becomes F into V plus V car upon V minus V car. This is the last solved example of your NCRT that talks about this, and this is given as 2F. So 2 is equal to V plus V car upon V minus V car. So 2V minus 2V car is equal to V plus V car. So what we have, V is equal to 3 V car, so V car is V by 3, so go for option B, which is a very high speed for car. Car is really going very fast. This is beyond comparison for us. Normal cars won't go like that. When a battery of EMF 8 volt with internal resistance 0.5 is charged by 120 volt DC supply using a series, this what is the terminal voltage? First of all, what would be the current? Current would be, because it is charging, both would be opposite, 112 upon total resistance, that is 16. So 112 by 6, that you know is 7 amperes. So the terminal voltage, because it is a charging mode, it would be V plus IR. So E plus IR, sorry. So it would be E plus IR, V terminal, not E terminal. We write it as V terminal. E is 8 plus 0.5 into 7, that is 11.5 volt. I can go for, I think this was asked before also as I think as an objective one. Long solenoid of cross sectional radius R has a thin insulating wire ring tightly put on its winding. One half of the ring has a resistance 10 times of the other. Okay. The magnetic induction produced by the solenoid varies with time like this, where B is a constant if the magnitude of the electric field strength in the ring is this, where P and Q are the smallest positive integer. What is the value of? Now this is the pick of the question. You can see here 1/2 has 10R resistance, let's say 10R, this is R. Due to the symmetry, both are having same change in flux, so the induced EMF will be same. So there will be some induced electric field to compensate for that. It will add up in this half with the EMF here, it will subtract it out. So if total induced EMF is E, we will have E by 2 in the first half plus this length pi A into electric field, that is the additional difference, that would be equal to I into 10R. Okay, I can write as capital R, it is given. And E by 2 minus second one would be pi R, half perimeter into E, that would be equal to I into R. So if I add them, E will come out as I into 11R, and E you can know is d phi by dt, that would be B into area, area is pi R square, that would be equal to I into 11R. So this is the first thing that we will get. So now put this value, I into I is what we get, B pi R square by 11R. Now put it in the first equation, let's say. So what we'll have, E by 2 means B into pi R square by 2 plus pi R into E, that is equal to I is B pi R square, 11, this becomes 10 by 11. So what we are getting, this pi R E is equal to 10 by 11 minus 1 by 2, 10 by 11 minus 1 by 2 would be 20 by 11, 20 minus 1 minute, 10 by 11 minus 2 would be 20 minus 11 by 22 into B pi R square. So pi and pi goes, so E comes out as 9 by 11 BR, that is what we are getting. So 9 and 11, that is P plus Q, we will get the value as P plus Q in this case should come up as 20. So that is the 11 and 9, or 9 by 22, sorry, what I did a mistake, 9 by 22, so 22 plus 9, that is not 20, that is 31 here. So this would be 22 plus 9, 31. So it's a very, very nice question. I think it would be really tough to imagine it first of all. Next, in a meter bridge, resistances are connected as shown. Balancing length is 55. Now an unknown resistance X is connected in series with P, and the new balancing is 75. What is the value of 11X? So what we have, P by Q was 55 by 45, that is 11 by 9. Now P plus X upon Q comes out as 75, that is 3 by 1, you have 75 by 25. So you can, what you can write, what is the value of the 11X? So just divide the both, because value of P is given. P upon P plus X is 11 by 27. So 27P is 11P plus 11X. So X is 16 by 11 of P, which is 4. If I have done it correctly, 16 by 11 into 4, yes. So what is 11X? 11X comes out as 64 ohms. So this is again an easy one. Next one. Carnot reversible engine converts 1/6 of heat input into work. That is efficiency is 1 by 6. When the temperature is reduced by 62, it's become 1 by 3. So 1 by 6 was 1 minus Tc by Th. When Tc is reduced by 62, it becomes Tc minus 62 by Th is 1 by 3. What is the sum of the temperature of the source and the sink? So from the first one, Tc by Th is 5 by 6. From the second, Tc minus 62 by Th is 2 by 3. So divide both. So Tc upon Tc minus 62 is 15 by 12. Or you can write as 5 by 4. So 4 Tc is 5 Tc minus 310. So Tc is 310. And what would be Th now? Th would be 6 by 5 into Tc. That is 310. This is 52. 52 into 6 2 is 12. This would be 362 Kelvin. So the sum would be 3 plus 3. That is 672. I can go for 672. Let me check. The 6 2 is 12. 1, that is what we have, 52, 6 are 6 2s are 12, and 1 3 1, I think some mistake, this is 62. Okay, let me do it correctly. This is 312, this is 62. So 6 2s are 12, 6 6 are 36, this is 372, sorry. So this would be 682, not 672. Be careful, otherwise the whole effort goes in waste. Next, amplitude of a pendulum is 10. When the pendulum is a displacement of 4 from the mean, what is the ratio of kinetic and potential? Kinetic you can write as half m omega square a square minus x square, and you write as half m omega square x square. So this ratio is a square 10 square minus 4 square upon 4 square, that is 84 by 16 that you are getting, if I'm right. 84 by 16, that is 21 by 4, that is we are getting 5.25 here. So that completes the paper. Thanks for watching.